Questions 21 to 25 on the 2009 Grade 10 Cayley Math Contest. A lattice point is a point with integer coordinates. For example, 1, 4 is a lattice point, but 3, 2, 4 is not. The line y is equal to 3x minus 5 passes through square PQRS as shown in the diagram. If the coordinates of R are 2009, 2009, then the number of lattice points on the line which are inside the square is. The first thing we need to do is figure out this point and this point. Where does that line first and foremost cross the x-axis right here? And where does it cross QR, the top of that square? If we can figure that out, then we can figure out the number of lattice points because we will have a range. So the first part, which is figuring out where does y equals 3x minus 5 cross the x-axis, is just looking at basically the x-intercept. To figure out the x-intercept, you set y equal to 0. So that means 3x minus 5 is 0. So that means 5 over 3 is x. So x is approximately 1.67. So this is right there, approximately 1.67. Now we have to do the same thing for that. So how do we figure that one out? That point is where y is equal to 3x minus 5 intersects with the line y is equal to 2009. So we set these equal to each other. So 2009 is equal to 3x minus 5, and therefore 3x is equal to 2014, and therefore x, if you calculate this, will be about 671.3. So this point, the x-coordinate, is 671.3. So lattice points are, of course, integers. So all the integers between 1.67 and 671. 2, 3, 4, all the way up until 671. Those are the values for x that will produce integer in terms of our coordinates. But we have to double check and see, is y also going to be an integer? Because the lattice point is such that both the x and y coordinate is an integer. Well, y is equal to 3x minus 5. So the good news is that no matter what you put in for x, no matter what integer value you put in for x, y will also be an integer, right? Because 3x minus 5 will always be an integer if x is an integer. So that's good. So that means all of these are valid. And how many of them are there? Well, that looks like 670 values of x. And therefore, you'll have 670 values of y as well. So the number of lattice points is 670, and therefore number 21, the answer is E. Suppose that a, b, and c are three numbers with a, b equal to 3, ac plus b equals 18, and bc plus a equals 6. The value of c is. Many approaches to this question, so I obviously want to incorporate all three. So let's see here, what's good to do here. I think I will add these two and then subtract this guy. That helps me get rid of some things. So for example, it will be bc plus a plus ac plus b, but then I'll subtract the first guy, so minus a minus b. And then on the right side, that is equivalent to 6 plus 18 minus 3. So when you do this, these a's go and these b's go, and that's what I wanted. So I'm just left with bc plus ac, and on this side, I am left with 21. Now, if you factor out a c, you get c times a plus b is equal to 21. Now 21 can be written as 3 times 7. So that means either this is 3 and this is 7, or the other way around. This is 7 and this is 3. So I got two choices. And c being equal to 3 or 7 are two of the answer choices. So I'm pretty confident that that's the right approach. Okay, so which one do I want to use first? Hopefully the right one. but it doesn't matter. If I get it wrong, I can always just choose the other one. So let's just say C is 3 and A plus B is 7. If that is the case, let's solve. If C is 3, then we have A plus B equal to 7. If A plus B is equal to 7, that is not possible. Why? Because A plus B is equal to 3. So very quickly we can eliminate that. And that's good, right? So that means the only other way is this way, where C is 3 and A plus B is, C is 7 and A plus B is 3. And that is valid. So I guess now we just have to figure out nothing, because we just figured it out. C is 7. So as you can see very quickly, with the right manipulation, you can get the answer. And just in case you're wondering, A will be 2.5 if you do the math. Not that it's necessary, but B is 0.5, like that. So number 22, the answer is E. Angela and Barry share a piece of land. The ratio of the area of Angela's portion to the area of Barry's portion is 3/2. They each grow corn and peas on their piece of land. Their entire piece of land is covered by corn and peas in the ratio 7/3. On Angela's portion of the land, the corn and peas ratio is 4:1. What is the ratio of corn to peas for Barry's portion? There's this piece of land, and it is split in the ratio approximately like that, and it's 3:2. So to make things easy, I always like to give a number, right? So let's just say the total land is 100 square kilometers, square feet, doesn't really matter. So it's 100. So that means that Angela, we'll put Angela here and Barry here. Angela's land is 60, and Barry's land is 40. Okay, because it's in the ratio 3:2. So that's the first part of the question. That takes care of this guy. Then we start talking about corn and peas, and they're saying that the entire piece of land, if you look at the entire thing, C over P is 7/3. Okay, I think we'll come to that a little later. Now let's talk about Angela. Her corn to pea ratio is 4:1. So that means of the 60, 4/5 is corn. So 4/5 of 60 is 48. So that's corn. And then the remaining 1/5 is peas. So that's 12. Okay. And then Barry's portion, that is what we actually have to figure out. Okay. So we don't know. So I'll just call it X for corn. And then for peas, it will be 40 minus X. Whatever's remaining will be peas. Correct? And then now is when we look at that total. C over P for the entire land is 7/3. So 7/3, corn for everybody is 48 and X. So that is the total amount of corn. And peas for everybody is 12 and 40 minus X. So that is 12 plus 40 minus X, like that. And that is the algebraic equation we now need to solve. So cross multiply and you get 144 plus 3x, and then this is going to be 52 times 7, 364 minus 7x, and then bring everything on one side and you get 10x is equal to 220, and therefore x is 22. So what they want is the ratio of corn to peas for Barry. So corn to peas for Barry is x over 40 minus x. So x is 22. So that means 22 over 18. And in lowest term, that is 11 over 9. So number 23, the answer is A. The field shown has been planted uniformly with wheat. At harvest, the wheat at any point in the field is brought to the nearest point on the field's perimeter. The fraction of the crop that is brought to the longest side is. The longest side is right here. So That is what we are interested in. Let's blow this up a little bit. Now let's talk about how are we going to approach this question. If some wheat is here, where is it going to be brought? Well, it looks like the closest side is here. Okay, great. What about if the wheat is here? Well, obviously, the closest side is there. And then similarly, if the wheat is here, the closest side is here. Now, sometimes it's obvious, right? But what about if it's here? I don't know. So what we have to do is divide this into some logical sections that will allow us to figure out the answer. Now, the first thing is I'm going to attempt to draw a line that's exactly halfway from the top to bottom. So approximately here. Okay. Now, this line, I have drawn it in a way that it is equidistant from top to bottom. Okay, so that means the distance from here to here is equal to the distance from there to there. So that divides this field into two sections. So that means if any wheat is in here, it's going to be brought to either there or perhaps to this side or perhaps to that side. Okay, but if any wheat is below this green line, it's going to be brought either here, here, or here. So that immediately eliminates this part. Now, I'm still not home free here because, sure, if it's below that green line, it'll be brought to here, here, or here. But I only want the wheat to be brought to the longest side. So what do I do now? Well, that requires us to draw a line that is cutting this angle in half. So something like that, approximately. And the same sort of scenario there, like that. What this does is allows us to section it perfectly. So now, anything that is in this part of the field will always be brought to the longest side because that is the side that it is closest to. And in contrast, if you had the wheat anywhere here, here, its closest side is the ones on the side. Okay, so that I think that's the challenge of the question, is trying to figure out what this region looks like. Now that we have the region, we just have to figure out the area of this region and then divide it by the area of the full field. Okay, so that involves a whole bunch of 60, 30, 90 triangles. So let's proceed with this. First and foremost, let's try to figure out the area of the total region. So to do that, I'm going to need some variables. I'm going to draw a top to bottom line there, top to bottom line there. And here we go. So this triangle, focus on this triangle here. This angle they told me was 60, and this is a right angle the way I've drawn it. So that's 30 degrees. So this is a 30, 60, 90 triangle, and the ratio of the sides are 1, 2, and root 3. So that means that if I have a top to bottom height, which I will label h, I can figure that out. Because the ratio of the sides is h over 100, and that is equivalent to root 3 over 2 in this particular triangle. So solving, I get h is equal to 50 root 3. And in a very similar way, I can figure out that side. I'll just call that b for base, I guess. So b over 100 is going to be 1 over 2. So that means b is 50. So this is 50. And because of the symmetry of this diagram, this is also 50. And this, from here to there, is 100. Correct? Because it's the same as that. So now we use the area formula for a trapezoid, which is area is this guy plus this guy divided by 2. So it's 100 plus, oops, I think I put too many zeros here. It's not 500. So 100 plus looks like 200 divided by 2 and times the height, which we just calculated as 50 root 3. So this looks like 300 divided by 2, 150. So 150 times 50 root 3. We'll just leave it like that for now. I think that's sufficient. Okay, so we got the area of the full. Now we have to concentrate on getting the area of this region. And if we do, we can then divide it by this big area. So in a very similar way, we're going to approach that. Hopefully this diagram won't get too messy. Again, I'm going to draw perpendiculars from top to bottom. And this time, the triangle that I'm looking at is this guy right here, this triangle. So this is, of course, a right angle. This angle now is not 60, it's half, right? Because that line chopped that 60 in half, so it's 30 degrees. I'll just put a 30 degree there, and therefore that's 60. So again, as before, the ratio of the sides of a 30, 60, 90 triangle, 1, 2, and root 3. Okay, so we can now use these ratios to figure out the side lengths. First thing I guess I'll do is just calculate the top to bottom h, and then I'll calculate this base right there. We'll call that b. So h over, well, it just dawned on me that h actually is just half of big H, right? Because the way we drew it, this is equidistant to that. So if this top to bottom is 50 root 3, then that means the small h is half of that. So h is just 25 root 3. So that's exactly how we drew the diagram, because the green line that runs horizontal chops that in half. So I guess now we just have to use b and h to figure out the value for b, and the ratio is root 3 over 1. So that means that b is equal to 25 root 3 times root 3, and that is 75. So if b is 75, that means this is 75, and therefore, since here to here was just 50, that means this is 25. So we got 50, 25, 50, 25, and then therefore the one in the middle has got to be 50. Not that that is really that important. Now we just have to figure out the area of our special region. I'll just call it R for region. Again, top plus the bottom, so the top is 50, plus the bottom, which is the same as the previous shape, interestingly, 200, and then divide by 2, and then multiply by the height. In this case, it's 25 root 3. And that's it. So this is going to be 125 times 25 root 3. And then now we just have to figure out the fraction. So that fraction is basically going to be this AR over this A. So AR over A is our fraction. And that is going to be 125 times 25 root 3 all over 150 over 50 root 3. So this looks like 5 over 6 times 1 over 2, and the root 3's cancel, so that you are just left with 5 over 12. And that is the required fraction. So number 24, the answer is B. Unit squares are arranged to form a rectangular grid that is m units wide and n units tall, where m and n are positive integers with m between 2n and 3n. The region below one of the diagonals of the rectangle is shaded as shown. For certain pairs m and n, there is a unit square in the grid that is not completely shaded, but whose shaded area is greater than 0.999. The smallest possible value of mn for which this is true satisfies the following. So what we will do is we'll put this on a coordinate grid and make it a little bit clearer for us, hopefully. So this is our coordinate grid. And then we've got this rectangular shape. And we are going to draw a diagonal. So let's draw that diagonal. And that diagonal has the equation y is equal to some slope times x. And because it passes through the origin, that's basically the form it will have. Now the slope of that diagonal is pretty easy to figure out because slope is just rise over run. And the rise, since it's n units tall and m units wide, the rise will just be n and the run will be m. So there's the equation of the line that represents the diagonal, n over m x. Now we have to concentrate on this part of the question where there's some unit square that's got a shaded area greater than 0.99. So obviously it's somewhere in here and we have no idea where it is. But what I'll do is I'll draw it over here. I'm obviously drawing it much bigger than it looks. It's going to be very small. And when you chop that with this diagonal, the diagonal will chop it like that, right? It has to do it like that because that's the only way you're going to get 0.999. It's actually even more dramatic in the sense that the cut, this part, is going to be very, very, very small because the full area of a unit square is 1. So they're only taking off a very small fraction. So the cut is probably like that. But obviously I have to draw it in a way that I can label it. So what we are interested in is this scenario right here. Okay? So when you have this kind of a cut, I'm interested in this point and I'm interested in this point right here. Those 2 points I'm interested in because I have to figure out what those are in order to calculate the area. Because that area is going to be the area of the unit square, which is 1, subtract the area of this tiny little triangle. And that triangle will be 1/2 base times height. So if I can figure out the base and the height, I can put in some sort of variables at least. And they tell me that this area is greater than 0.999, 1 minus 1/2 base times height. If I put everything on one side, I get 1/2 base times height is less than 0.001. So that makes it a little bit better. This is what we're going to deal with. Okay, so now let's go back and figure this out in terms of coordinates. What I'm going to do is first and foremost label this corner right here. That corner I will just call something. I'll call it AB, let's say. Okay? And therefore, because this line has the equation y is equal to n over mx, that means that this point right here has the same y coordinate, correct? So it is of the form b for the y coordinate, and the x coordinate will be m over n b, right? I just took that equation and isolated for x. So far so good, right? In a very similar way, this coordinate right here is going to have the same x coordinate as AB. So it's going to be a, but then the y coordinate I get from that equation. So it'll be n over m a, like that. So that is how we label this diagram, and that allows me to figure out base times height. So this equation now becomes 1/2 base. Well, the base, I can use that part. So it's going to be, let's see here, m over n b minus a. And then the height is from there to there. So I use the y coordinates. So it's going to be b minus n over m a. And that is, of course, less than 0.001. And this is what we have to deal with. So this is our equation. All right, so let's proceed now. Let's do a little bit of manipulation, because eventually we have to figure out what is mn. What is the range? It's going to be between two numbers. All right, so how do we do that? Well, the first thing, of course, let's multiply through by 2, get rid of that fraction. And if we do, this is what we get. B minus nm over a. And that is going to be 0.002. And then let's see here. If I'm going to try to get rid of these fractions here, I don't like these m over n, that kind of stuff. So let's multiply everything by mn. So times everything by mn. And if I do, I will get, let's see here, m squared b minus mna. And then this will just remain the same, since we only have to multiply one bracket. And this becomes 0.002 mn. And then if you multiply this out, it becomes m squared b squared minus mnab minus mnab plus n squared a squared, and that's less than 0.002 mn. All right, so far so good. Now this guy, obviously we have to factor, and it factors very nicely. mb, mb, and then na, na, like that. And minus, minus, I believe. Yeah, minus, minus. And that is less than 0.002 mn. Okay, so far so good. And then multiply through by 500. That will get rid of that very small decimal. So this becomes 500 times mb minus na all squared is less than mn. There we go. So we got it down to this form. And keep in mind that m, n, a, and b are all integers. So that's going to be very helpful. So now let's discuss this guy right here. mn is greater than this, right? And this part is a perfect square. So a perfect square obviously is going to be positive. It could be 0, but 0 would not make any sense, right? It could be, but that would just give us that mn is greater than 0, and that doesn't help us. If this is 1, it helps us, because that means that mn would be greater than 500 if this part is 1. Okay, if it's 2, then it becomes very big. If it becomes 2, then it would be 2,000. And that's not helpful. Why? Because look at our answer choices. This is one of those questions where the answer choices really are going to guide us. mn is only going to be anywhere between 500 and 520. We just identified that it's got to be greater than 500, so we can immediately eliminate A. But we still have to figure out, is it between 501 and 520? So going back, this part here is not useful. So the only way we can figure out mn's actual range is to look at this guy here and concentrate on that. And in particular, I want mb minus na to equal 1. And it's the only way that we can figure out mn in terms of its upper boundary. Its lower boundary is obviously 500. It's got to be greater than 500 because that's positive. But what about its upper boundary? What is it less than? Well, my answer choices tell me that it's anywhere between, what is the 505 and 520. Okay, so that is my sort of range. Okay, no problem. So I've got to figure out 4 integers that when you multiply them and subtract them like that, it equals 1. Now, do I have any help? Yeah, a little bit of help. Not too much help, but the first thing the question told you that m is between 3n and 2n. Okay? Another thing that we can immediately identify from our diagram is that a and b are both less than m and n, right? If you go back to the diagram, you can see that clearly, that this square right here was somewhere in here. So obviously this a and b that I chose has to be less than m and n. So that's pretty obvious, I think, but it helps us. So at this point, I will let you do the fiddling around, meaning how to figure this out. I don't think you want to hear me go through every single number from 501 to 502, 503, and that's just going to be very monotonous. But when you do figure that out, right, you get to the following conclusion, that if m is equal to 34 and n is equal to 15, this will work. And the choices for a and b are b equals to 4 and a equals to 9. And if you do that, you can verify 34 times 4 minus 15 times 9. That is 136 minus 135, and that is indeed 1. So now we are interested in m times n. Well, m and n are 34 and 15, and 34 times 15 is equal to 510. So 510 is the upper boundary of this. And of the answer choices, the only one that matches that is right here, and that is choice C for number 25.